Okay, hi everyone. We're Group Malaysia. We have Kai Shen Cheng, Joey, Jiayi Wong, and Junshen Yap. And together from Group Malaysia, we present to you the light rail transit database model. And the motivation for our project was we were thinking for a project idea, we thought what was the main struggle for college students like us, and what problems do we face while studying at the UNL? And for specifically for international students like us, our main problem is transport. We can't get around the school very easily and cost effectively. So what we thought, is there any solution to this problem? And so we came up with the light rail transit. Next slide, please. And so we, for our project, we modeled a fully automated light rail transit database that operates from Lincoln to Omaha in Nebraska. It is supposedly a more faster, more efficient, and eco-friendly alternative to buses and ride-hailing services like Uber. And this is a project that would be worth committing to after this course with the potential to make a difference, especially for Nebraska and the University of Nebraska-Lincoln. And I'll pass it
Now,
to Joey.
now I will talk about the entity relationship diagram. This diagram visualizes how the different entities in our system are connected and interact with each other. We have the city with the unit identifier of city ID and the name, and it has linked to the station with the reading relationship with a one-to-many relationship. And then the station has the station ID as the attribute and the name, the coordinate that is the latitude and the longitude of the station. And it is use the follow relationship that use one-to-many relationship to schedule. And the schedule also have a schedule ID and arrival time. And it's linked to the route with one-to-many relationship in track relationship. And the route also have a route ID and name. And there's a triple connection right here between station, route, and travel, which the travel has the travel ID with distance, speed, and duration, and they are linked using the connect relationship. Going into our relational database schema, because we have the many-to-many relationship between station and route, we have that connect as a table with primary key of connect ID, foreign key of start ID, and end ID that is from the station ID, and then the route ID from the route table, and the travel ID from the travel table.
And for our data sources, we chose 12 popular locations across Omaha and Lincoln. And then we used the Google Maps to obtain the geographic coordinates, the longitude and latitude to identify the train station. We then computed the routes and distances between stations using piecewise linear approximation. We assumed the train operates at an average speed of 80 miles per hour. Then we calculated the travel time based on the distance and speed. And this is a raw data example of our data. And as you can see in the timetable, we put the speed as 80 miles per hour. And for the station, we chose the real geographic coordinates.
Now I'll explain the data transformation process that we follow in our data project. This we use the vec2 constraint to transfer our coordinate to the constraint database. And these are the map of the Lincoln, Omaha, and Nebraska. As you can see here, the orange is the Nebraska map, and then we have Lincoln in blue and Omaha in green.
All right, with our next data transformation, we're using piecewise linear approximation to find the route of each train in between each train station. So we use the p-line MATLAB function provided by Professor Revez, and by inputting 12 coordinates, which is the x being the longitude and y being the latitude, and setting the error tolerance to 0, we got 12 different constraints, which when we put it in the MLPQ, we would get the image of the route. So as you can see, we have two tables down, the north and the south spatial data, and you can see the route on top. So that ends our data transformation there. So we wanted to combine the both of them to see how they will look like together. And as we can see in the top image, we can see Nebraska with Lincoln, the small little dot that's Lincoln and Omaha. And there's a line connecting the both of them. So if we zoom in to that image, we can see the route of the train stations in between those two cities right there.
And now we'll be talking about our implementation and demo. For our first function, it's about the city and station access. It's to find the possible destination within the city using our train system. And we use basic SQL for this, where we input the city name, and then the output is a list of stations within the city. And if we extend our project to other cities, we also can use this function to find the list of cities using this. And our second function is the total duration calculator, where we measure how long the train takes to travel an entire route. We use an aggregate SQL for this, where we input the route ID and it outputs the total duration. We can also use this to find the total distance.
Our third function is the arrival time estimator, which allows the passenger to assess the approximate arrival time based off our light rail schedule, given the route ID and the station ID. And then we will output the time of the train arrival. To use this, so for example, if you are going to this station in this route, you can estimate what time you should arrive at the station before the train arrives. Our fourth function is the real-time station locator, which allows the user to assess which station the train will arrive at a given time according to the schedule. So you can input the arrival time and you will get the station and train route at that given time. So for example, if you know what time at that time, where would you be? So you can input the arrival time. For example, right here is 8 a.m. That is 480 minutes start from midnight. And then you will get the station and route at a given time. That is the South Points. Yeah.
All right, and to conclude our presentation, these are some of our final takeaways. What we found really enjoyable with our project was we were able to depict the entire blueprint of our light rail transit using MLPQ and the constraint databases. And we just thought that overall, by using the entity relationship diagrams, relational database schema, all the visualizations, and all the implemented functions, we were able to provide Nebraska with a possible solution to our public transport situation right now. And just the idea of being able to make Nebraska more accessible, that was kind of fun. Apart from that, in order to find specific arrival times and destinations, we had to hard code a lot of the information into the data. That kind of defeats the purpose of the logical aspect of creating a ERD. So that's something that we want to work on in the future to make it more efficient. And lastly, the ER diagram had to be reconstructed several times for it to be functional for us. So it would have been way more smoother if we use other types of queries as well, such as recursion and nested. And to touch on that, these are some of the limitations that we face and the things that we want to work on in the future. One thing is real-time train location and arrival time predictions. So kind of like what I spoke before in the previous slide, a lot of things were hard-coded. So our goal is to provide the train location at any given time, whether the train station is still operating or not, and like what time you arrive at certain places. That's what we aim to achieve. Enhancing train integration would be one of our goals as well, such as including more trains into the database system, more stations across the two cities, or even expand it to a different city, and more efficient routes. Because currently we only have two types of routes, one going from Lincoln to Omaha and one returning from Omaha to Lincoln. So maybe having like an internal loop in the cities would be more efficient for our designated users. Another thing that we want to improve is having a customer database. Having that would allow us to keep track of their information and also account for pricing or like train memberships and that kind of stuff. So that's something that will be useful in the future. And lastly, to make the blueprint more realistic and incorporating elevation into our model would be more helpful by using the triangular irregular network. I believe that's what it's called. But yep, thank you so much for listening to our group. Please let us know in the comments if you have any more questions. But Group Malaysia, peace out.